Okay, so you guys have your test review for your work, power, and energy test tomorrow. So just kind of scrolling through this. All right, physics, work is defined as force times distance times cosine of theta, but as the question asks, it is this answer. Unit of work is the joule. Also, the unit of energy. All energy is the joule. Power is defined as the work done on an object divided by the time taken to do the work. So letter C. Unit for power is the watt. Unit of force, still the Newton. Here, what you had to do, work done by dragging a box across the floor. You push with a force of 235 newtons, and it moves a distance of 21. You multiply them together, you should get letter D. Number 7, how much power do you generate dragging that box from the problem above in 15 seconds? So you would take this answer, 4935 divided by 15, comes out to be 329 watts. So you have the weight of a person. That's great. There's 600 newtons. The elevator lifts that person. All right, that has a force of 600 newtons, a distance of 6 meters in 10 seconds. So F times D gives me W, and then W divided by T gives me power. So I can literally just replace that and just do F times D divided by T gives me power. Answer for that should have come out to be 360 watts, letter B. Object that has kinetic energy must be moving. Energy is changed from one form to another with no net loss or gain. That's always true. What are the two factors that are needed to find kinetic energy? Mass and velocity. It's in the equation. Potential energy is the energy an object has because of its height and location. All right, our gravitational potential energy, height and location. Calculate the amount of potential energy a 50 kilogram object will have when it is held at a height of 2.5 meters above the floor. So H is 2.5, M is 50. You need to know that G is 10, mass times gravity times height. So 50 times 10 times 2.5. You get your answer here. How much work is done by holding a 15 Newton basket while waiting in line at a grocery store for a time of 180 seconds? The answer is 0. Why? Because you're not moving the object in the distance of the force. Pendulum swinging back and forth. So as a pendulum swings back and forth, what is true regarding what's happening there? So basically, I think I gave you this. No, it was on the little exercise that we did yesterday. So essentially, if this is our pendulum, okay, so as it rocks back and forth, the height is the least amount here relative to the ground. So kinetic energy is the maximum here. It is max at the ends because it has the largest height, and in between it is transferring back and forth from kinetic to potential. So letter D. Number 16, rank them from greatest potential energy to, rank them from least to greatest potential. I thought this was great. So this should technically be the reverse. Technically should be the reverse. So, least to greatest. There you go. Got my own little mistake. Guys, please stop talking as I'm going through this. Thank you. Least to greatest. Potential energy is basically lowest to tallest height. Lowest to tallest height-wise. So instead of it going from A, E, B, D, C, it's going to be the reversed. So it should be C, D, B, E, A. Okay, so definitely, that was even my fault. I tricked up on that. looking at it too quick. List the points in order of greatest to least kinetic energy. So in this case, it would be the opposite of most potential to least potential. So in this case, it actually is the same. All right, the kinetic is going to be the greatest here because potential should be 0, then D, then B, then E, then A at the top. And mechanical energy is the sum of both potential and kinetic at any point. No. Absolutely not. No. So you guys here have a conservation of energy problem. You have the mass of a cow, mass of a cow, mistake, standing on a hill, 100 meters long, and a height of 36 meters. So the total height. So they want to know what is going to be her velocity at point B if at point A she's moving at 11 meters per second. Since the mass of mistake doesn't change, we can cross out the m's in this problem, which leaves us with 1/2 vi squared plus gravity times initial height is going to equal to 1/2 vf squared, which we don't know, plus g times final height. Substitute our numbers in. All right, at point A, it says in the problem they're moving at 11 meters per second. So 1/2 11 squared plus gravity of 10 times the initial height at point A of 30 equals 1/2 vf squared plus gravity of 10 and final height here of 7.5. Figure this out. This side is going to equal 360.5 equals 1/2 vf squared plus 75. You have to subtract 75 from both sides. That leaves you with 285.5 equals 1/2 vf squared. Got to multiply both sides by 2 to get rid of the 1/2, which would leave us with 571 is equal to vf squared. And then to get rid of the square, you have to square root both sides, giving you a final answer of 23.89 meters per second. Okay, here you're given force, distance, and the angle. So they give you the equation. Work is force times distance times the cosine of the angle. Here, multiply them out, you get 945.87 joules. And in the part 3, they just want to know how much work are you generating if, in this problem above, you did it in 32 seconds. So you take your answer from part 2, divide it by 32, and it should come out with 29.55 watts. And the final piece. At the top, they give you both kinetic and potential. You need to know that by adding them together at any point is going to be the mechanical energy, ME. So if you know that you have 100 and 0, mechanical has to be 100. So that means when you add PE and KE at any of these points, they have to add up to be 100. So if you know what 50 potential energy, 50 joules here for potential energy, kinetic has to be 50. If this is the same height, so 50 and 50. Height at the bottom, 0, so you should have 0 joules, which means all the energy has to be kinetic, and this is the same height as over on the bottom, so potential of 0, kinetic of 100. So then, basically at the very end, you just have to find the velocities. Using the equation at the top, 2 times kinetic energy divided by m. Mass of the ball in each one of these is 2 kilograms. So for part B, it would be 2 times the kinetic energy of 50 over the mass of 2, and that's where you get the 7.07 from. And then for the spots where the kinetic energy is 100, it's 2 times 100 over 2 square root, giving you guys 10 meters per second. All right.